When you try to change the way people think, you tend to have a lot of obstacles.
The scientific community, the people who build this, as well as the clinical community, thought like it's a known truth. You cannot do this.
I received a lot of pushback from colleagues and friends to not start down this route, that it was extremely risky, that it would never work out.
It's been absolutely 17 years of poverty. Very little money, very, very little money, just hanging on by my nails, trying to get this product to go.
I myself was affected by an autoimmune disease when I was very young, when I was 15 years old.
I thought that the technology market had already crashed and bottomed, but it hadn't. So there were a lot of dry years after that, trying to get going.
Why do I do what I do? To make a difference in people's lives.
I do what I do because I love interacting with people.
I was curious, and now I think I can make a difference.
And why I do what I do in terms of administration, something that many academics try to avoid, is because I like to feel part of the institution. The more I know about the way the institution works, the more I can help the institution to grow and move towards a better future.
It was out of watching medics in the field that I came up with the ideas for devices that would save lives at the point of injury.
I do what I do because I think it's important for youth to explore the career options that are available to them, such as science and technology.
So why do I do what I do? I love it. The science is exciting.
Why do I do it? It's because every day is different.
Innovation, changing the way we do things is very much a personal satisfaction for me.
I do what I do because I've seen the thirsty, the dying people. That's why I do it, because if I can do my small part just to alleviate the sufferings and the death all around the world, then it's worth it.
So it's great for us to come every morning and we know that we're going to try something new that will help people.
Tonight, we add to ASTech's long-standing legacy and introduce the world to 25 new heroes in science and technology. Heroes who heal the world. Like Dr. Gino Falone and his team, who successfully integrated two technologies previously thought to be incompatible, benefiting many cancer patients. Through the successful coupling of MRI and LINAC technologies, Dr. Gino and his team have created the LINAC MRI system, the only system that will irradiate tumors without margins, minimizing radiation to healthy tissues.
You see the actual tumor in soft tissue beautifully. We track the tumor, and wherever it is, it just grabs on it and follows the shape and the position. With this system, not only will we treat all the cancers that are presently being treated by radiation oncology, which is a vast number, we're also be able to treat a whole new series of cancers, which had never been an option for radiation treatment in the past.
And then there's Dr. Per Santamaria, who has changed how we understand and treat autoimmune diseases. Dr. Santamaria has employed the tenets of nanotechnology to invent a therapeutic vaccine that can resist chronic autoimmune responses.
It's potentially revolutionary because it has the potential to afford treatment to many diseases using one single design, drug design, that resets the immune system to its healthy state.
His work not only has the potential to radically improve the health of patients, but can also reduce healthcare spending internationally, nationally, and right here in Alberta. Dr. J. Gregory Cairncross has developed a treatment for a chemosensitive brain cancer that has doubled the median survival from 7 to 15 years.
We found out that if you give the chemotherapy we were using just before the radiation, patients live twice as long with this cancer than if you just give radiation alone
and hold the chemotherapy in reserve. So actually swinging harder at the beginning gives a better result. We subsequently determined that whether you responded or not to this chemotherapy program was determined not by anything but its genetic makeup.
Dr. Seema Gupta and Dr. Rajan Gupta have taken the processing times for certain clinical tests from 2 weeks to a matter of minutes.
Nanospeed is developing some diagnostic technologies which are meant for point-of-care testing.
Our technologies makes crucial personal health information available to doctors and patients immediately through portable devices that doesn't require any equipment or expertise and can be used for patient management across the globe.
Their work with nanospeed technology can be applied across a broad spectrum of healthcare, agri-food testing, as well as oil and gas sensing needs. There are those who provide better tools to equip first responders in the field to control severe bleeding.
Bleeding is one of the leading causes of preventable death. So most people will die before they get to a hospital. If they arrive to a hospital alive, they'll likely survive their injuries. The IT clamp is a device that will stop bleeding within a few seconds of any open injury, whether it's a gunshot wound, stab wound, shrapnel injury, by sealing the skin shut, generating a pool of blood under pressure, forming a stable clot until you get to surgery.
Innovative Trauma Care is slated to launch the IT clamp by the end of 2012. This technology will help save lives. Some people heal the world by creating research tools, such as the KMT mouse, that allows therapeutic companies to save money and animals during their safety and efficacy testing.
The problem was really brought to my recognition about 15, 17 years ago when I saw how many people we were transplanting in our liver transplant program for hepatitis C. We only had about a 15% rate of success. Seeing that, it became apparent that perhaps we could help. We started to look at ways to generate basically a mouse with a human liver to allow ourselves to generate a way to support the virus infection. But the real impact that we hope to have and that we see ourselves having is an opportunity to help generate a possible cure for the hepatitis C virus infection.
Dr. Brianne Everett is demonstrating leadership with the development of improved treatment for diabetic foot ulcers. She is delivering sensor-based products and sensory substation systems that allow people to better cope with disease, improving their overall quality of life.
The problem of diabetic peripheral neuropathy is huge. It affects about half of diabetics. And of those patients that it affects, it can lead to devastating complications like ulcers, infection, and amputation. So what we're doing at Orpix is we're creating pressure-sensitive insoles for these patients that enables them to have that feedback loop that they don't otherwise have.
Some heroes heal the world by visualizing the complex anatomy of humans through means of sophisticated software, allowing users to interact with the human body on a touchscreen. Meet Lindsay, the virtual human, a real-time project created by Dr. Christian Jacob and the Lindsay team that combines state-of-the-art information technology with medical expertise, creating a truly innovative solution for education, training, and research alike.
What I hope the Lindsay project would lead in, say, 5 to 10 years is that we not only are limited to medical schools, but also get into physicians' practices. Then the idea is to integrate CT scans, so 3D data from patients that we can superimpose with the model.
Some people are heroic because of how they impart knowledge with others. The ones who educate. Heroes like Dr. Gregory Taylor, who clearly understand that many of history's great discoveries happen at the interface of traditional science disciplines.
If you can bring good people together and have them be a part of imagining the future and where it goes, give them responsibility, give them authority, give them accountability, that things progress much more effectively that way.
Dr. Taylor has been the Dean of Science at the University of Alberta since 2002. Over the past 10 years, His unwavering commitment to creating an interdisciplinary science center has resulted in the state-of-the-art Centennial Center for Interdisciplinary Science, CCIS, a perfect place for future breakthroughs. For the past 39 years, Dr. Anthony Russell has been a presence in the Department of Biological Sciences at the University of Calgary, performing research, imparting knowledge, and contributing as a faculty member. Dr. Russell is well regarded as raising the science and technology profile of Alberta to new heights, particularly through his work with the Calgary Zoological Society and the Royal Tyrrell Museum of Paleontology. Some organizations exercise heroics by making knowledge more readily available than previously thought possible. For instance, HatSize Learning Corporation. HatSize is the leading cloud automation software provider for hands-on demos and training.
I always really enjoyed learning, but I didn't necessarily enjoy the way that learning was normally done in schools. I started this company so that we could provide other people with the types of opportunities that I wanted to have myself.
They bring training administrators, instructors, students, and employees to the knowledge they need to be connected with at any computer, anywhere in the world. Christy Burke understands the important role having fun plays in the learning process. As manager of Destination Exploration Youth Science Programs at the University of Lethbridge, Christy has not only expanded existing programming and created new initiatives for Southern youth, she is now instrumental in bringing the 2013 Canada-wide Science Fair to the U of L for the first time in the university's history.
I'm passionate about what I do because I'm passionate about education and about creating opportunity for more children in our community.
Captivating Albertans as it zooms through communities far and wide, the Schulich Axiom Solar Car is more than just a car. It's a vehicle for inspiring all Albertans to learn about sustainable technology in all aspects of living. Recognized in scientific communities throughout the world, the University of Calgary's solar team is responsible for helping build a brilliant reputation for the U of C, the City of Calgary, Alberta, and all of Canada.
What we do is we build and race a solar car, but more than that, we actually go out into the community and we do school visits, we do public events to educate people around Alberta on the impacts of sustainable development and specifically solar vehicle technology. It's really inspiring to us to see how excited they are. It makes us excited and want to keep on doing what we do.
Okay.
Through outreach to high school students and the general public, Dr. Whedon and his team are helping create the next generation of scientific entrepreneurs. Students are challenged to solve real-world problems, learning the gamut from basic to applied science.
iGEM stands for the International Genetically Engineered Machines Competition. So in iGEM, what we do is the students get to design their own genetically engineered biological machines.
Attracting the attention and support of industry, the iGEM team is working on a product that could play a key role in the remediation of tailings ponds in the oil sands.
At the international competition, the names of the 4 shortlisted teams, and it says Stanford, Yale, Washington, and Lethbridge. That made my day.
And then there are the kinds of heroes who make Alberta more competitive on a national and global scale by giving others the opportunity to build their own success stories. John Masters is known for initiating the merge between U of C's Technology Transfer Organization and Calgary Technology Incorporated to create Innovate Calgary, the go-to place and hub for the technology sector for programs, service, and incubation space.
The light turned on for us to say, we need to grow an Indigenous technology sector from within the community and have a vibrant ecosystem. In most cases, these are brilliant individuals and/or small companies, but they don't have the management resources or potentially the financial resources, and we're there to assist them.
There are heroes who help connect Alberta with the rest of the world. One in particular is Dr. Marvin Fritzler, an outstanding ambassador for the Alberta science and technology community, who has always thought ahead by being a builder and a leader of organizations within Alberta. Dr. Fritzler has selflessly shared all of his knowledge and experience to help connect Alberta with the world outside its borders.
I guess my determination comes out of the fact that I was born and raised in Alberta, born on a farm not far from Calgary. And so Alberta has become part of my soul, if you like. And so my determination is wanting to make a difference in the province of Alberta.
Some people go to post-secondary to follow in the footsteps of others. Christopher Skapik, on the other hand, is the type to lead by example. Having served on almost all of the U of A's senior governance committees as a PhD student, Christopher has also published 8 research articles, presented 16 abstracts at premier international and national conferences, and received 3 different graduate student research awards. And he's showing no signs of slowing. Christopher is now an MD student at the U of C, where he plans to take on more of a national advocacy role by serving as a student representative to the Canadian Medical Association.
Some of the research I've been doing is we've been looking to try and diagnose different diseases. So what we've actually been able to do is come up with a diagnostic for asthma using a urine sample.
Professor in the Department of Chemical and Petroleum Engineering, the Director of the Schlumberger Center for Simulation and Visualization, the Director of the CMG Frank Sarah Meyer Collaboration Center, all jobs at the University of Calgary, and they all belong to Dr. John Chen.
And we're developing the simulation technology for oil and gas production and development. And we try to utilize the best technology available, the best data available, to improve the simulation technology.
A world-renowned expert in the field of pipeline research, Dr. Sean Sanders is one of the people equipping the next generation of oil sand researchers and practitioners. A highly skilled workforce is critical to ensuring Canada's oil sands are developed in a reasonable and sustainable manner. Dr. Sanders is helping see this through.
We've come up with some ways where we're able to actually transport mixtures that have very little water in them. So that means that you can get rid of the water early on in the process, recycle that back to the front end for reuse, and that means it's not going into a tailings dam.
Bridging the world's academia and industry is Drader Manufacturing Industries. Drader has collaborated with a research team of mechanical engineers at the U of A to design a customized methodology for plastic product development and troubleshooting for molding processes. The result of this joint research will give Drader scientific insight into product reliability, failure mode prediction, and material use effectiveness.
So we were able to model the part, look at it in a 3-dimensional model and say, okay, here's how it's breaking. Here's the forces applied to that corner, to the breakage to cause it. And then once we were able to reproduce that, we knew what area we had to target to strengthen the part.
Some people are heroes because of their exemplary environmental stewardship and commitment to creating a safer Alberta. Scat dogs sniff out new answers for environmental performance in the oil sands. Using the detection dogs, fecal samples from caribou, moose, and wolves were located with high precision. The safety and health of animals in Alberta in correlation with the development of the oil sands are ensured because these canines have a nose for, well, poo.
Well, it's a very innovative technology, and that's what's so exciting about it.
Dogs collect very efficiently over the landscape. We take the sample, we tell who it was, and then we look at its physiological status. We look at the actual location where we found the sample, and we put that onto a geographic information system that maps all the different habitat disturbances around, and we're able to ultimately tie all this together to figure out what's going on in the system.
When it comes to livestock, there's a lot on the line. GrowSafe Systems employs a team of multidisciplinary engineers and scientists who work together developing intelligent systems that automatically measure biometric and environmental inputs. Not only do they enhance animal well-being, GrowSafe also minimizes environmental impact through feed-efficient strategies which reduce manure and methane output.
You can now individually identify an animal and individually treat an animal and individually monitor an animal. It's a paradigm shift in the cattle business.
Internationally recognized as an authority in the field of mathematical biology, Dr. Mark Lewis has raised and helped resolve issues of importance to Canada, global society, and ecology.
You're speaking two languages because you have to be able to speak to biologists and you have to be able to speak to mathematicians. So what I do and what my lab does is we build bridges between these two different ways of thinking, and it's when you can connect them that the fun things happen.
Using mathematical models, Dr. Lewis has demonstrated how multi-species competitive systems can lose linear predictability as parameters change, essential work when it comes to the spread of harmful invasive species. Pristine beauty, nature at its finest. But there's more going on than what immediately meets the eye.
Most years in Western Canada, or in Canada, we lose about 12 to 15 people, and that's almost all recreational.
Working together, Dr. Jameson and the departed Dr. Shea have developed an objective data-supported process for using thermal imaging on snowpacks. And they have used thermal imaging results to contribute to avalanche forecasting and education.
We're really interested in temperature differences, and that was one of the great bright lights I think that Cora came up with, is that these differences, these temperature gradients over a millimeter or so, are quite stable. They don't change after the pit wall has been exposed for 2 minutes, and that gives you enough time to take the picture. And that just took us up, got all kinds of new ideas about what the thermal camera could do for snow science, in particular for avalanche forecasting.
Many people work to create more fresh water for the world. When Trilogy Environmental Systems does it, they are more than just a little bit efficient. The overall efficiency of Trilogy ESI's hybrid water desalination system is typically between 50 and 80%. And in the world of water desalination, this means significant energy savings. And what's better is that it's completely mobile.
In Canada, we have the most amount of fresh water on Earth, and we don't realize the rest of the world is suffering for water. In India, 300 million people that live on the coastline, there's water all around them, but they don't have a drop to drink.
I feel a lot of my friends and they're my age group that I grew up with are now, onto that stage of family and kids. And so with science, it's the sacrifice you make is having to put that on hold for 5 or sometimes even 10 years. But I wouldn't change it for the world.
When you take out a new idea, every door closes in your face and you must be determined to overcome that.
I'm determined to make a difference in the world and move forward that technology because it is feasible and it is doable.
Because this path of developing a product is not the beaten path in medicine for sure. It took a lot of, I think, courage in proceeding with it and telling my staff and my peers what I was doing, just because it usually invokes a response like, why are you doing that? I don't understand.
One could draw an analogy to golf. If you want to go from being a 5 handicapper to a 0 handicapper, you have to work very hard. It doesn't happen. Yeah, it doesn't happen overnight. Yeah, you have to really put in the hours and the blood, sweat, and tears.
Tell me about some challenges you've had with the program.
Challenges?
Yeah.
It is science. Every single day is a challenge, okay?
You got to be a little bit of an idiot, to be honest with you. You just got to be very single-focused and have that absolute belief in the bottom of your belly that you're doing the right thing. And then the rest of it will come by itself.
It's often not important to look at the windshield and see the bugs on the windshield, but to look in the rear view mirror on occasion and see what's happened. And when you have that perspective, you can see that the challenges actually are overcome.
I think Alberta is an excellent place for science and technology because of the pioneering spirit that exists over here.
And I think I'm privileged to be able to work in a line of work where I can have fun, and at the same time, I may have the opportunity to help others in a very substantial way.
And when you actually have success in your experiments and your research, you can really just envision the impact that it's going to have, not just on my career or even this university, but Alberta, Canada, just the world in general.
And I think if you tell me it cannot be done, I'll do it.